Okay, Assalamualaikum. Hi. So now we meet again on the part 2 under chapter 6, spectroscopy method. So previously we know about spectroscopy. So how does the energy transform, and how does or what is the difference between absorption and emission spectrum, and what are a few types of the transition involved. So now we learn on the another new terms, which are transmittance and absorbance. So what does it mean? So transmittance is the ratio of the radiant power passing through a sample to that from radiation source. So basically these are the sample container, or we can call it as a cuvette if we use a spectrometer, UV spectrometer. So the P naught is the electromagnetic radiation that inside on the sample from the source. Okay, whereas the PT is the electromagnetic radiation exit from the sample, and the B is the width of the sample container. So the T here is PT over P naught. Okay, and usually the transmittance we will display as a percentage of the transmittance. So the percentage of transmittance is PT over P naught times 100%. So if no light is absorbed to the sample, therefore the transmittance is 100%. So if the transmittance is 100%, the absorbance will be 0. Okay. However, when the light is transmit everything, so the transmittance is 0 and the absorbance is infinite. Okay. So these are how the absorbance and transmittance transform in the spectrum. Okay, so in absorbance, it shows the absorbance number on the y-axis versus the wavelength. Okay, and the transmittance in terms of the percentage of transmittance over the wavelength. And usually the UV spectrometry will show the absorbance result, but we can play with that equipment. Either we want to get the transmittance or the absorbance. Same goes to the infrared spectrometry. Okay, so next we learn on the Beer's law. So what is the Beer's law? So Beer's law is the law which used for the spectrometry. So it will show the relation of the analyzed absorptivity, sample thickness means the width of the sample container, and also the concentration of the analyte. Okay, so the A absorbance is equal to negative log T, and is equal to ABC, where the A is the analyzed absorptivity, B is the sample overall thickness, and the C is the concentration of the sample. So these are the schematic of a simple spectrometer by the Beer's law. So we usually the main component consists of 4 components, which are the light source, the wavelength selector, the sample itself, and the detector. Okay. So as an example, so let's have a look at the example carefully. A sample in a 1 cm cell is determined with a spectrometer to transmit 80% light at certain wavelength. If the absorptivity of this substance at this wavelength is 2.0, what is the concentration of the substance? Okay, so the transmittance is 80%. Therefore, the T is 0.8. Okay. So the concentration of the substance is 0.05 gram per liter. So next example, a solution containing 1 mg ion in 100 ml was observed to transmit 70% of the incident light compared to an appropriate blank. So what is the absorbance, and what fraction of light will be transmitted by a solution of iron if the concentration is 4 times higher? Okay. So the absorbance is 0.155 and the transmittance will be 0.240. Okay, so next, please try this following exercise. Calculate the concentration of HCl solution and NaOH solution. Okay, so this figure shows the Beer's law is a relation between absorbance and concentration, which is a straight line, passes by origin at constant path length and at certain wavelength. Okay, however, when the absorbance is more than 1, the Beer's law will not be obeyed. Okay, as the curve is not, the line is not a straight line, it shows a curve. Okay, meanwhile, for the transmittant decrease exponentially as concentration increase. So we can see from this figure down here, when the light transmit from the source to the sample, it will reduce the transmittant to certain value, but it will not reduce to the 0%. So therefore, there are few limitations on the Beer's law. First of all, based on the fundamental itself, where the law is only valid for the low concentration analyte. At higher concentration, there will be interaction between particle of analyte that may change the absorptivity. Therefore, the line will not be straight anymore. Okay. Second, based on the chemical. So the absorbing species is involved in an equilibrium reaction. And the third one, based on the instrumentation itself. So the Beer's law only valid for monochromatic instrumentation. Okay, so the effect of leakage light from imperfection within wavelength selector, this phenomenon is called stray radiation. So it does not suit for the X-ray radiation. And also, Beer's law is limit when we use incorrect cuvette or sample container. Okay, so that's all for part 2. See you on the next part. Bye!